In this video, we will talk about the electronic oscillator and we will learn about the basic working principle of the oscillator. They are used in laptop and smartphone processors for generating the clock signals. Hello? 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 Can you hear me? While they are also used in a radio and mobile receivers for generating the local carrier, which is used in the lab to test the circuits. So, this oscillator accepts the DC voltage and it generates the periodic AC signal. Now, the oscillators can generate the frequencies from Hz to GHz. Now, the output of the oscillators can be either sinusoidal signal or non-sinusoidal signals.
Assalamualaikum and hello. My name is Muhammad Shazwan bin Hanafi. Alright, now it's my turn to tell you about the main type of the oscillator. The main type of oscillator: Windbridge, RC phase shift, Hartley, voltage control, Colpitts, clap, crystal, Armstrong, tune collector, gun, cross couple ring, Dynatron, Meissner, optoelectronic, Pierce, Robinson, treated, Pearson, Anson, delay line, Royer, electron couple, and the multi-wave oscillator. Alright, now I will tell you about some of that. Alright, this is the Windbridge oscillator. It is a type of phase shift oscillator which is based upon a Windbridge network, like figure 1a. It comprising of 4 arms connected in a bridge fashion. Here 2 arms are purely resistive while the other 2 arms are a combination of resistor and capacitor. In particular, one arm has resistor and capacitor connected in series while the other that has them in parallel. This indicates that these 2 arms of the network behave identically to that of high pass filter or low pass filter. It's making the behavior of the circuit shown by figure 1b. Alright, that's all from me and we go to the next member. Thank you.
So, I will continue to the next part, which is component of oscillator. First is amplifier. Amplifier used to increase the voltage, current or power of a signal. Usually, amplifier is used in audio. Usually, we can see amplifier used in electrical guitar to increase the sound of electrical guitar. But in oscillator, we use the amplifier to increase the voltage. Second component is wave shaping network. Wave shaping network is used to control the frequency and shape of the wave produced. So, we continue to the next component, which is positive feedback path. As we know, oscillation needs a movement that repeatedly with a regular rhythm, such a pendulum bob that's swinging to make an oscillation. Positive feedback path will create a loop in a circuit without external input signal. The output signal is fed back to amplifier input through the positive feedback path. So basically, oscillator accepts the DC voltage and generates the periodic AC signal of desired frequency. So this is the diagram of the oscillator circuit. A DC voltage will be the input of the amplifier, and the amplifier will generate an output. But how they work? In order to make an oscillation and generate periodic AC signal, the feedback circuit must be added. So, the feedback signal will act as input for this amplifier. So, the feedback signal will be added to the input signal, and input signal will be removed. Value of output is equal to A times input voltage. The value of feedback voltage is equal to beta times V output, which is equal to A beta times V input. The value of A times beta is called loop gain. The value of A times beta will determine whether the oscillation will be sustained or not.
Assalamualaikum. My name is Rodadi Zikri Beruzman, and today I'm going to explain about the condition for the oscillation. There are three conditions of oscillation that can occur. First, the loop gain is greater than 1. Second, the loop gain is less than 1. And the third, the loop gain is equal to 1. All of these three conditions will be explained further in this video. But before that, let's look at the simple circuit of the amplifier with the positive feedback to understand the basic principle of the oscillator. Once the power supply is on, the oscillation will initiate due to the electronic noise present in the system, and it's travel around the loop and converge to the single frequency sine wave very quickly. So let us refer to the diagram given. As the voltage pass through the amplifier, the gain of amplifier, which is A, will be multiplied to the V in. So the V output, we can written it as A times the V in. So let's say the input to the feedback is the output of the amplifier. So the gain of the feedback, which is beta, will be multiplied to the V output of the amplifier, and it is written as A times beta times V in. So let us say that we cut off the voltage input toward the circuit. So the V input for the amplifier is now supplied by the V output of the feedback. So whether if we can get the self-sustained oscillation is depend on the product of A and beta. This product of A and beta is known as the loop gain. So the first condition is the loop gain is greater than 1. The oscillation will increase in the amplitude. As you can see from the diagram, the oscillation is getting bigger and bigger. So this will cause the output to be distorted. The next condition is the loop gain is less than 1. The oscillation will be damped and the oscillation will dies out. As you can see from the diagram, the oscillation become smaller and eventually become zero at a certain amount of time. And lastly, the loop gain is equal to 1. This is the desired output or desired oscillation that we want to achieve on this oscillator. So as you can see from the diagram, the oscillation occur with constant amplitude, and it will lead to the self-sustained oscillation.
Everyone, now I will share some of the application of oscillators nowadays in our market. First of all, I will share about the application of the LC oscillator. LC oscillator is a type of oscillator where the LC tank circuit is used for giving a required positive feedback for sustaining the oscillation. The LC tank circuit is also termed as LC resonance circuit or LC tune circuit. First example is radio receiver. Radio receiver is a wireless or radio is an electronic device that receives radio wave and convert the information carried by them to a usable form. It is used with an antenna. The antenna intercept radio wave and convert them to a tiny alternating current which are applied to the receiver. So the last example for LC oscillator is RF generator. RF single generator provide a signal oscillator is RC oscillator. RC oscillator is linear electronic oscillator circuit which generates a sinusoidal output signal. It is composed of an amplifier and frequency selective element. A linear oscillator circuit will use an RC network, a combination of resistor and capacitor. Application of RC oscillator is function generator. It is a piece of electronic test equipment to generate different types of electrical waveform. Some of the most common waveform produced by the function generator are sine wave, square wave, triangular wave, and sawtooth wave. The next example is signal audio generator. Signal audio generator is run over the audio range typically from 20 Hz to 20 kHz and more, and are often used as sine wave generator. Application is crystal oscillator. Crystal oscillator is an electronic oscillator circuit that uses the mechanical resonance of a vibrating crystal of piezoelectric material. It is to create an electrical signal with a precise frequency. The crystal oscillator is also widely used in nowadays computer and digital clock. The UJT relaxation oscillator is called so because the timing interval is set up by charging of a capacitor and the timing interval is ceases by the rapid discharge of the same capacitor. Example of application of UJT oscillator is cathode ray oscilloscope or CRO. The CRO are used to analyze the waveform, transients, phenomena, and other time varying quantities from a low frequency range to the radio frequency.